Then you can record now.
This is theory and I'm gonna take you through trigonometry. Well, I hope you recall very well in our last topic that we discussed. I want to thank you that you participated so well. And here we are, we are gonna take you through trigonometry. And this is what you learned from your O level. That was, I think, Form 3. Yeah, and I think you know some part of the trigonometry. For example, the signs of like sine, cos, and then the tan. So here we are going to take you through the advanced trigonometry, as you see on the chalkboard. When we talk about trigonometry, it has a definition that states trigonometry is the study of relationships between sides, length, and the angles of the triangle. Angles of the triangle. How old you know about the triangles that we studied ever since our primary levels? We've been talking about triangles and the shapes, and of which you learned about the right angle triangles, what in your primary 4, 5, and 6, and 7. The equilateral triangle, the isosceles triangle, and here we are going to exploit the right angle triangle and furthermore of these triangles. Well, hope you all know that the right angle triangles, as shown on the figure, you all know it has that one angle that makes the 90. And for today, we are going to exploit more about it. And well, the right angle triangle, by definition, you can write right angle triangle is these are triangles having one angle equating to 90 degrees. And therefore, since you know that the angle sum of the triangle is 180, and then hope you can easily just find the sum. The summation, if you know the sum of the angles in the triangle add up to 180, you can easily find some of the various angles. Using that knowledge, you got from 5 and blah blah. So, okay, let's exploit the right angle triangle in the means of trigonometry. So here we go. Since you know from your primary, you said about the Pythagoras theorem, and then the Pythagoras theorem states, as you see, a squared plus b squared equating to c squared. Hope you are well conversant with that. And then you all learn about the SOHCAHTOA. SOHCAHTOA in your senior 3. SOHCAHTOA, just a simple form that helps us to know further trigonometry. Yeah. And then we have the sine standing for the s, and cos standing, and the c standing for the cos, and t standing for the tan. You all know that sine is just the opposite over the hypotenuse. Just as you see from here, from our angle, the theta, if we're just taking the sine of theta, which is the opposite, and giving us a b, as you see here, and the hypotenuse giving us the c, as you see there. We shall come up with the expression as b over c. Well, then we shall also have to exploit out the cos to see its equivalence from our right angle triangle. And then our cos will be from the trigonometry that we all know, cos theta of this angle from our right angle triangle. It will be the adjacent, as it is denoted by the A, and the hypotenuse, which is denoted by the C. Well, since we want to use our Pythagoras theorem, and we have already exploited some of the unknowns you see here from the Pythagoras theorem, we also have them here. So we shall have to know their equivalence. Since we know that B, from here, we know that B over C is equaling to the sine theta. Hope we can easily find out the value of B from this expression. We shall find or make B the subject of that expression, which will easily give us a C cross multiply, you can just easily get it out. And here we come with expression. Well, and definitely we shall also get to know the equivalence of A from that expression. Since we know that A over C is given by cos theta. It also represents cos theta from that expression. Therefore, our A will be, a C cos of theta. So, furthermore, we shall come and substitute our equivalence of A and B in this expression of pantographic theorem. And all we know that A is given by C cos of theta. This is written here. And we have to square it because our A is squared. Then plus the C sin theta representing our B, equivalent to the C squared. So, as you know, when we are applying the squares, it has to substitute it. So, okay, so you have to, it drops to the C and also it drops there. Cos theta. So we shall come up with the expression of C squared cos squared theta. As we are squaring this, since some of you have been just seeing the mere sine, cos, what, the square comes here in between of the angle and the sine. Like that, which is just easily written like that. So from this expression we shall get C squared cos squared theta plus the C squared sin squared theta equal to C squared. Therefore, since you can see something in common, we are seeing the C's, they are very many and the C's are squared. So we're going to factorize out the C squared. You already know that from our form 3 factorization method. Hope you're welcome with that. When we factorize out the C, we shall have a C out. We shall also remain with the cos squared theta plus the sin squared theta. That's written in this. And when you expand this, you shall easily go back to this. Because when you expand the C squared cos squared theta, we shall get this. And then C, when you multiply this by that, we shall get the C sin squared theta. Hope the same thing. We'll have to and from the factorization, we shall come up with something like cos squared theta plus sin squared theta. Just as that. Simply, this is one of the basic trigonometric identities that it is a must know. Each and every both of you have to know because we are going to exploit more of the trigonometry. You have to be on sure with this. Definitely, for today we have a quote. We must assume knowledge and wisdom about everything. Because you know, from your primary, you've been hearing some of you, your primary mottos were knowledge is power. And then wisdom is the key. What intention is the success. So when you have the knowledge and combine it with the wisdom, that is the perfect thing. That's above all.